Hello data lovers, I hope you all are doing super amazing. I hope you had a really great time with your family and with your loved ones in Diwali. So again, happy Diwali to each and everyone. Today's video is definitely really different, or you can say I am going to create this kind of video for the very first time, how to design a basic data pipeline. And this is going to be helpful for all the aspiring data engineers who want to understand the key responsibilities of a data engineer and how to design a very basic data pipeline. So anyone who is completely noob into the data engineering, this video will be really helpful. Let's say if somebody gives you a problem statement to design a data pipeline, then what all things you need to keep in your mind before designing that data pipelines. In total, what will be the baby steps to design a basic data pipeline. In the end of this video, I will be giving you a very small task which will be related to designing a data pipeline. So make sure you watch it till the very end. Definitely you will learn a lot of things from this video. And also if you want me to create another video where I should come up with a proper code implementation of that basic data pipeline, then let me know in the comment section. What do you actually feel about this video which is related to data pipeline design? Let me know in the comment section so that I can come up with more and more design related questions. Alright, so when we talk about the ETL processing, right, the basic ETL processing, we all know this is basically the extraction, transformation and the load part. So in every single step, we need to focus on few points which are really important to design our basic data pipeline. So let's look at what all those things we need to focus on in each and every single step, right? Even it is related to data or framework, whatever it is, let's look at it. So first part is definitely the extract part. In the ETL processing, extraction, which is related to data extraction. Second part will be the transformation, right? In the transformation, our task is basically to apply the business rules, and in the third part it is actually related to the load part, right? So anyone who have basic idea about the data pipeline, so in the data engineering there will be two concepts. Either we will be doing the batch data pipelining or real-time data pipelining, right? There is one more which is in between among these two, like near real-time data pipeline design. So we will talk about these things in later videos in depth, but here for the sake of the simplicity, right, when you actually design the data pipelines, or based on my 5 years of experience in the data engineering, I have seen in the industry 80% of the time you will be working on the batch data processing, right? And batch data processing is nothing. Let's say you are waiting for some time to data to be collected, and then after that you are just triggering your data pipeline to apply some transformation. That is the batch data pipeline. So for the simplicity, mostly we'll be talking about the batch data processing part so that it is very easy for you to understand the fundamentals. So when it comes to the batch data processing, so in the data extraction part, right? So in the data extraction part, the thing you need to focus, like what would be the source? What would be the source, right? And in this case, our sources can be multiple. And since it is not the real-time data processing, so majorly these sources will be any persistent file storage system, like which will act like a data lake. You can say the HDFS, or even you can say AWS S3, right? So this is one example from where you can get this kind of data which is in the batch form. And second can be any NoSQL database as well, right? You can directly make a connection from the distributed computation frameworks to this kind of NoSQL tables and get the data from there and process it. And third can be your warehousing service as well. Let's say if you talk about the open source framework, so Apache Hive is also a kind of warehousing service. So from those distributed computation frameworks, you can make a direct connection to Hive table and you can read that data. So third source can be the data warehouse service, right? Data warehouse service. And another example can be your SFTP servers, right? Means any kind of server where, let's say, your clients or any process is dumping some data, right? So these could be the potential sources of the data from where you can get it when it comes to the batch data processing. And once your source is finalized, right, from where you are going to get the data, second thing which you need to focus, what would be the format of that data, right? So in this case, the basic file formats like JSON, CSV, Parquet, ORC, right? So these kind of very popular data formats we know in the big data, right? So you need to figure out what kind of data, what kind of format of the data you are going to get here. And when it comes to JSON, obviously it will be a semi-structured data format because the schema is very flexible, attributes are flexible. When it comes to CSV, it will be a kind of formatted data in the form of row and columns. When it comes to Parquet and ORC, these are the file formats which will be compressed and in the columnar format and very well supported for the analytical queries. When this part is done, then with respect to the batch data pipelining, third thing will be the identify the schema, right? This process is very simple, nothing, just do the initial data exploration, that how this data actually look like and what all attributes are there, what are the data type of each attribute, how this data looks like, right? So that you can apply proper serialization and deserialization to read this data and enforce your schema, right? So these are the very basic things or the fundamental baby steps you need to follow while creating your data pipelines. Do you struggle to speak English fluently? Do you not feel confident around the people who speak English really well? Or are you simply looking for the tips that can help you to learn a new language efficiently? Then Cambly can solve this problem for you. Cambly is the only app in the India which provides one-to-one private English classes with tutors from the USA, Canada and UK. It is especially very useful for those who know how to read and write but struggle speaking English confidently. On Cambly app, you can choose these lessons and classes for different courses like business English, personality development, IELTS, etc. And the best part of the Cambly app that its tutors are very friendly and supportive, and they will help you to improve your weak areas without any judgment. And on the platform itself, you will find different tutors from different geographic location. You can watch their profiles and decide which tutor you want to pick, and you can take classes from it. You can download Cambly app from anywhere and start practicing English in one-to-one classes with native speakers. And if you will use a special link which I have provided in the description and coupon code, then you can get a trial class with the tutor. So hurry up, download the Cambly app and avail this offer. And when it comes to design a very effective, efficient and optimized data pipeline, then there will be more and more complex fundamentals will be used, which I'm not covering because it is again related to very basic concepts, very basic fundamentals. So that's what I'm talking here. And again, sorry for my bad handwriting, bear with it, but focus more on my words, what I am actually explaining. So after the extraction part, the next part in the ETL processing will be the transformation, right? So in the transformation part, major thing we need to figure out, and that is the most crucial part as well, right? That what kind of framework we should actually look for. So this will depend on multiple factors, right? Multiple factors. First thing, right? What kind of data you are going to process and what is the frequency of it. And when it comes to frequency, it strictly means that whether you are going to do the batch processing or near real-time or real-time data processing. If you have any use case where data is getting produced in the form of stream, that means it is a real-time data processing. As soon as you receive an event, that means you are processing it. And wherever you have the use cases where you need to wait for some time and then process the data, then definitely it's a batch processing. So based on that, you need to decide what kind of framework you will be using. So for batch processing and for near real-time data processing, obviously Spark is something which is wonderful. For batch and near real-time data pipelines, near real-time, we can definitely go ahead with Spark. And when it comes to real-time data processing, obviously we can use Flink, Apache Flink here. Real-time, Then we can go ahead with Flink. Framework will depend on multiple factors, that what your company is actually preferring. Let's say they are completely on the cloud part, so they might be using something like AWS EMR, AWS Glue, or something from the Azure or something from the GCP. But eventually under the hood, those cloud services are also using Spark and these kind of frameworks basically to process your main data. So everywhere you will go, you will definitely find these frameworks to do the actual job. So you cannot get away from it. And let's say you only have your data in the data lakes, right? Your data lakes, for example, AWS, S3, HDFS, right? Or NoSQL databases. So here, let's say you directly want to compute something, right? You directly want to query the data which is actually available in the data lakes, or this extraction, right? The HDFS or S3. You can even use Hive, right? Which is a kind of data warehousing service, but under the hood, it processes everything in the form of MapReduce. So again, a distributed computation. So you can use that one as well if you have the use cases where from this transformation section, you don't want to do complex transformation and you are not bothered about the processing time, because again, Hive is something which is a typical MapReduce, so it takes time to process. But when it comes to Spark, definitely it does the in-memory processing, so its runtime is very, very fast. The next thing is apply business rules. Applying business rule is nothing. Whatever problem statements you have got from the business teams, and now you are aware about the data source, just read those data sets in your application and apply those business rules so that your data can be transformed. So once transformation part is done, the next phase will be load part. So in the load part, right, the thing or the kind of question you need to ask to yourself, that what will be the destination, right? Destination where you want to load the data. And when it comes to the load part, this transformed data can also be stored into the HDFS or S3 or any NoSQL database or any kind of data warehousing service, right? Data warehousing service, because this is something which will depend on the end use case, right? So let's say you had this kind of transformed data, and this is also very big in terms of the storage, and from your business team, it is the requirement that whatever data you will transform, just load it in a kind of data warehousing service so that it can be directly queried, right? So what will happen, either from this transformation box, right, within our Spark application, we can even make a direct connection to Hive, right? And we can load our transform data into the Hive itself, right? The internal tables of Hive, and that data will be queried directly from there. Or let's say company is using any cloud kind of warehousing service, for example, AWS Redshift. So we can use that connector and directly load our data into the Redshift table. But let's say the end use case is to get that transform data into the persistent storages like HDFS and S3, so that later point of time some external tables can be created on top of it, or let's say this intermediate transform data can be used by other application for further processing. Then we will be again dumping our transform data into some HDFS or S3 location, and even same thing can be loaded into the NoSQL database for other type of analytical queries or even the dashboarding, right? So you can have multiple kind of dashboard tools, let's say Tableau, Power BI, and let's say you have loaded your transform data into Cassandra, MongoDB, Elasticsearch, or these kind of NoSQL databases. With the help of those dashboarding tools, you can make a direct connection and you can just visualize that data, whatever transform data you have stored in this NoSQL database. So these are the very, very fundamental things and the baby steps to move ahead with the data pipeline designing part. That's why I said I haven't covered the complex things related to the validation, orchestration, data backfilling, and all those complexities, because just a first step to understand how this data pipelining and the ETL processing works. In the extraction part, what you need to focus on, transformation, how you need to decide, the frameworks, and in the load part, how you need to load the data, where you need to load the data. Now the task which I wanted to discuss, and I want you guys to complete it. You can pick up this task and get it done. You can share it wherever you want on your social medias. You can create a GitHub repository and put this task in the form of code to your GitHub repository. But I definitely want you to pick up this task, and especially to all those aspiring data engineers or the noob data engineers who are just starting with the data engineering fundamentals and how to design a data pipeline. This will be a really good exercise for you. So the task is very simple. You need to design a batch data pipeline in your local system, right? So first, what you need to do, actually the requirement part, right? In the requirement part, what all things you need to have, right? First thing, install Hadoop. Install Hadoop. Why? Because here we want to use HDFS as our source location. Means whatever huge amount of data we will be having, HDFS, which is kind of distributed file system, so our source data will be stored there. That's why you need to install Hadoop in your local system. Second part, you need to install Spark, Apache Spark, which will do the actual computation part, right? Apache Spark. And once these two things are done, you would also need to install the Airflow, right? Apache Airflow, which is basically the orchestration or the workflow manager. So if you remember this part, right, where I was talking the frequency. So if you have any application written, right, application which is your Spark application or anything, so in order to process it time to time, you need to trigger it, right, with respect to that frequency. Let's say every 1 hour, every 5 minutes, every 10 minutes, or every a week or every day, you want to trigger your data pipeline to read some data and process it. You need to have such kind of orchestration tool or a workflow manager, which is Airflow, very popular, so that you can schedule your job, you can orchestrate, you can maintain those dependencies, right? So Airflow, this is something which you need. And fourth thing, you also need to have Apache Hive. You need to install Hive as well. And once I will explain the problem statement, then you will get the idea that what this challenge is all about and why all these things are actually required. So your problem statement is very simple, right? Your source will be HDFS, where your data will be installed. And in your HDFS, what you need to do, right? You need to create one folder, right? One folder will be named as input, right? And within that, you will be storing the data, and that data will be sales data, and it will be like 𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 sales data. Every day you will be getting the sales data, and the file which will get created under this folder will have this sales data as a prefix and the current date as this suffix part, right? So let's say today is the 26th of October. So how this input data will look like: sales data underscore 2022, then 10th, then 26.csv. So that every day you will be getting the data, right? Every day file you are getting here. So within this input folder, you will see this kind of data file each and every day, and that's what we need to process. So what will be the schema of it, right? First, let me write, this will be your step 1, and sales data schema. This is the data you can actually mock by yourself, right? So the schema is very simple. It will have 3-4 fields. So first is the customer ID, right? And second will be the order ID, and third will be the order date, This is something you can create it by your own. You can create an empty file, have these column names, and just write some random records by your own. Order date, order status, it can be cancelled, delivered, returned, right? Order status and total amount for that particular order, right? So this will be the sales data schema. So this is our source part here. Now what you actually need to do, the problem statement, which is the step 2, right? Step 2, write the Spark application or anything you want to prefer, Scala, Java, PySpark, whatever. Write Spark application, to read source data from HDFS daily and compute below stats, right? So these stats you can even prepare by your own. First, let's say how many successful orders, cancelled orders, right? Second matrix, you can calculate how many orders each customer placed each day. Third, how much amount each customer spent on that particular day, right? So this is the part you actually need to write. So in your Spark application, what you need to do, you need to read the data from the HDFS. But now the point which you need to focus on, that how to make this thing dynamic, the orchestration part or this scheduling part, which is the step 3 and the most important part, because in our problem statement each day we are getting one file for that particular day. So every day, right, let's say 12 p.m. afternoon time, we are triggering our data pipeline. So it should only read the data for that particular day. So what you can assume here, by 6 a.m. or 8 a.m. you have received the input file for that particular day, right? Let's say it is 26th. So you have received that data, and by 12 p.m. what you are trying to do, you are trying to process that data. So 12 p.m. afternoon time, you are triggering your data pipeline. So with the help of your Airflow, right, or the orchestration tool, so first of all you need to write your Spark application in such a way so that it can accept the dynamic parameter. The date value will be dynamic here, so that you can apply the regex part and you can only read the data for that particular day. So how it will actually happen here? So here, let's say this is your Spark application, which is scheduled, right? Like this is your Spark application. Let me write what you need to do in the step 3. Schedule the job for each day only once, right? So this will be our third part. Schedule the job for each day once. So this is our Spark application, and this is our HDFS, right, where you can say the source data is here, and from Spark we will be reading data from the HDFS, but this is our Airflow, right? So Airflow, here we will configure our application which we have written, we will configure it in our Airflow, and this will be scheduled, right? Automatically 12 p.m. it will trigger itself, right, by 12 p.m. and it will see the commands, right? In my command it is written that I need to trigger this Spark application. So let me write it, trigger by 12 p.m. right? So this Airflow job will actually trigger this Spark application, and input parameter, what it will pass, the input param, it will be the today's date, right? So if you are able to pass this current date as a parameter to this input Spark application, and this Spark application also using the dynamic, right? It is not hard coding the date value within the application itself, like the way you have coded it. It should accept this parameter which is coming from the Airflow, right? And it should use that one, and then somehow you need to convert your input date value in this format, right? You need to write a regex so that you can point to that data file which has arrived for today. So that's how you are going to make it dynamic. So this was the orchestration part, and now in the step 4 it will be actually related to the aggregation and the data analysis with the help of Hive. So here you can actually see we are doing multiple transformation. This is transformation 1, transformation 2 and transformation 3. So at the end, every day we are calculating some aggregations, and per day wise aggregated data we need to dump it into the HDFS again, right? So for that one, what we are going to do here, we will dump our data into the HDFS location with some proper directory structure, so that we can create external Hive tables on top of it, and with the help of Hive we can read this data and analyze it more, right? So how it will be done? The load data into HDFS, right? So first, let's say you are doing the transformation 1, because transformation 1 we are calculating something. It will have the order and the cancelled order and the delivered orders, right? So it might have only 2-3 attributes in the final resultant schema. When it comes to the, let's say, third metrics we are calculating, where each customer how much amount it is spent for that particular day. So it will have only 2-3 columns, the customer total amount and the date on which he or she spent the total amount, right? So in that way, what we can do in the HDFS, we will create this kind of directory structure, let's say output, and within that one we will have, let's say, trans 1 means transformation 1, and within that the date kind of folders will be created. So let's say today 26th of October you produced some resultant data, right? So again you need to store it in the .csv form. So here how it will look like, 2022 underscore 10 underscore 26 and then a forward slash. So this is your directory structure, and here it will be like result 1 dot csv. So result 1, basically what it means, this is the result for transformation 1 and .csv format, and this was something which was produced and generated for this 26th of October. And this one, if at any point of time you locate your position at this one, that means you are getting the data, that means you are getting the transform data for the 26th of October only, right? So that's how multiple structures will be here, even for just transformation 1, right? So it will be 2022 10 27, and again here it will be result 1 dot csv, right? Now when it comes to store the result for, you can say simply transformation 2, so trans underscore 2, then 2020, then 10 26, like result 2 dot csv, and so on. So what will happen in that case, you can create individual external tables to analyze the transformation 1, transformation 2 and transformation 3, right? So in this step 4, you need to create external Hive tables for each transformation, right? So create external Hive tables for each transformation so that you can analyze this whole section which is related for the transformation 1, second table which will be for transformation 2, third table which will be for transformation 3. So you will be having access on complete historical transform data. So at any point of time you can just access it and analyze it. So that's what I had for you guys in today's video. I'm pretty sure you would have found it really insightful if you are an aspiring data engineer. And if you find it meaningful and you think that this is something which can help anyone to just know the building blocks of data pipeline design, then make sure to like this video in the big numbers. Share your opinion and thoughts in the comment section. What do you feel about this video? And if you want me to come up with this solution for this task as well, then let me know in the comment section. So I will see you guys in the next week with another amazing stuff. Till then, just keep exploring and keep loving data.